Hello, and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. For today's show, we've got something that isn't about electric vehicles, but we're really lucky to have Dr. Ben Upcroft with us, who is the VP of Technology at an amazing company called Oxbotica. So welcome to the show, Ben. It's really nice to have you with us.
Thank you so much. What a real pleasure to be here.
And I wondered if we could get started just with a bit of background on yourself, Ben, and how you got into doing what you're doing now. Where did it all start?
I've been involved in science and excited about science, I think, ever since I was a little kid. I actually did a degree in physics. So I wanted to understand how the world worked. But I kind of wanted instant feedback. And physics is a long, slower burn. Yeah. Engineering really attracted me at that point. And I've had this kind of underlying, wish to understand artificial intelligence, and robotics has got to be the epitome of that, right?
Yeah.
So I went from a physics degree and went into robotics, and I was really fortunate to work with some of an amazing group of people who did field robotics. What I mean by field robotics is deploying actual autonomous systems out into the real world, into mines, underwater, in aerial type vehicles.
Yeah,
it was super exciting times. And I've been involved in robotics for 20 years. Almost 20 years. It's a bit sounds a really long time now that I say that out loud. But it's also given me a real privilege to be on a journey from when robotics was maybe more thought of as a research project, doing small things indoors, to seeing that what it is today. Yeah, autonomy in our streets, in industry, around the globe, and I've really been fortunate to be involved in that. I've deployed autonomous vehicles in mines, quarries. That includes haul trucks and drag lines. That's kind of where I got started.
Right.
And that moved into all sorts of platforms. So underwater vehicles, we mapped out parts of the Great Barrier Reef using computer vision alone to do 3D reconstructions. That was super exciting. And doing similar things with aerial vehicles. I've really always been drawn back to terrain vehicles, wheeled vehicles. And the reason is I think there is an interaction that happens with the world that really requires intelligent behavior to move through that world and do it in such a human-like way.
Yeah.
And so I joined Oxbotica about 4.5 years ago in exactly that vein to move and advance autonomy and autonomy in all sorts of vehicles. I'm responsible for the software, the algorithmic side of things, and all the way to the processes and deploying that onto an entire system.
Yeah.
So it is a very exciting place to be.
Wow, it sounds fantastic. I tell you what's really interesting as well is that you use the term robotics. That's it's quite. I think there's a lot of hype around autonomous vehicles and autonomy. But the robotics and autonomous robotics, and your kind of entry point being through the robotics side of things, it's really really interesting to me, that is, and I think, I guess, leading on from that is the first question, because you touched on it a little bit there. What is it that you do at Oxbotica?
Yeah, so I agree. Robotics is kind of maybe the heart of autonomy and autonomous systems, and it brings together both the requirements for intelligence and the embodiment that you need in an agent in the world. So I think robotics really started this off, and autonomous vehicles is one aspect of robotics.
Yeah.
You can use the technology from robotics and autonomous systems, not just in an autonomous system. I think there's so many different cases in which you can leverage the technology that is provided by robotic and autonomous systems. What's Oxbotica about? So Oxbotica was founded in 2014 by Professor Paul Newman and Professor Ingmar Posner. We have offices in the UK and in Canada, and we're continuing to expand. We've had a lot of growth over those years. We provide a software autonomy platform. We're a pure software company. However, that software is deployed into the real world, a 3D world with hardware. The underlying principle around our software autonomy platform is universal autonomy. And what I mean by universal autonomy is that it's the idea that machines know where they are, know what's around them, and using that information, understand what to do next, understand how to intelligently plan through the world.
Oh, wow, okay.
Our software, that software platform, our autonomy platform, is very flexible in the sense that we deploy and provide autonomy into many different domains. That's off-road, on-road, mines, quarries, airports, ports, public urban roads for delivery, and as such. So it's a really flexible and capable system that allows us to go into many different places.
So is that your software is the sort of the brain of the autonomous vehicle? It's taking kind of inputs from sensors and things and making decisions about what it should do with the drivetrain and which direction it should go in, and should it accelerate or should it brake? Is it kind of doing that sort of level of primitive control over the vehicle?
Yeah, you could really think about it as the brain. We also provide maybe you can call it the ecosystem that supports that brain as well. So you need to be able to do exactly what you're saying, make intelligent decisions around the inputs that are coming, that are input into the system.
Yeah.
But you need a support structure around that as well, just like a brain does. You need to be able to understand and give our vehicle certain goals, for example. You need to be able to control maybe an entire fleet, and those goals might be a general goal for the entire fleet. That ecosystem, that cloud software is also provided by Oxbotica.
Okay, yeah. A lot of people would think of an autonomous vehicle in terms of a single car, like driving from your house to your work and kind of making decisions about how to do that. But actually, in a lot of the applications you've mentioned there, where it's a mine site, you might have 20 or 30 or 40 vehicles of some of the same type and some of different types, all kind of working together. And they've all got to know what each other's doing. And I guess is there sort of some element of planning to what the most effective use of those vehicles is, from like a mission kind of profile of how you kind of manage and control those in the fleet?
Yeah, I think that's really key to where Oxbotica fits in. Look, there's the places that we work in, mines and quarries and airports, as you suggested, have a whole network and understanding around logistics in which they are trying to work towards. We provide the interface to the autonomy, the brain, for example, the autonomy software platform that we provide for them to be able to do that most effectively, the best way they know how. So mines know how to operate, mining operators know how to operate their own mine. They've done it for many, many years. They know how to do it very efficiently. We don't pretend to be experts in that, but what we are is experts in the autonomous system. So what we're doing is providing an input, an ability to communicate to that system so that a mine site or an airport can leverage what autonomy brings, and the productivity, the efficiency gains, and benefits and costs as well.
Yeah. Oh, fantastic. So, and how do you deal with all the sort of different kinds of vehicles and machines and all that? There must be such a huge degree of variation between the different kind of things that you're trying to give that intelligent control to.
Yeah, so I think that plays to the universal autonomy principle that I was talking about before. I think we've designed the software so that it is flexible enough to be able to work in many places. We haven't baked in any assumptions about those domains. We haven't relied on any infrastructure, external infrastructure, particular to a particular domain, for example. So one of them being GPS. So we're not reliant on GPS. The vehicle itself is completely self-sufficient. However, we can leverage information from GPS if it's available. Why we've not relied on GPS is it allows us to be able to work in places that GPS might degrade or it's just not available at all. So indoors, for example, underground, or even in urban canyons. Just a couple of examples where that occurs, where we might lose GPS or it degrades. Also, the other infrastructure I'm talking about. Lane markings, for example. Lane markings are very different on a public road than they are in an airport, for example.
Yeah.
And the rules of the road are different accordingly.
Yeah.
So baking in assumptions about particular lane markings means that you're not able to work in those other domains. Now, you need to use that information because you need to be able to behave appropriately and intelligently in each of those domains. But what we do is not bake it in from the foundation, and we add that on at the end. Now, you were talking about the different platforms that you might work in. We've really thought really hard about how we can deploy our system onto many different vehicles. And one of the, I think, strengths of Oxbotica is our power requirements, or very low power requirements. And you need to have low power requirements if you're working on small electric vehicles, but you also need to have be able to leverage what you have on large mining type vehicles as well.
Yeah.
In fact, some of our installations are use up less than 300 watts. So it's something that we really work hard on. Our engineering team is super proud when they shave off milliseconds off a particular algorithm or a particular processing pathway, and all those milliseconds add up. And so I think that's another part of this universal kind of underlying principle that we have. Any place, any type of vehicle, and I think another part of it is the type. You have to be flexible in the types of sensors that you might work with. So we are very agnostic to the types of sensors. There's a diverse set of sensors out there that you might want to use. And as I was saying, we're not reliant on any external type sensing. So GPS, for example, it's all on the vehicle that we use, and that allows us to be in each of these domains and operate efficiently and effectively.
Yeah, and is there like some sort of, I don't know, like a driving test? Do you have, if you're deploying the software on a big mining truck or a small, delivery vehicle, how do you kind of test it to make sure that it knows what it's doing, or how do you train it to make sure it knows what it's doing?
Well, I think that's a really huge question. It comes down to providing the confidence that this system's safe in each of these domains, isn't it? You need to be able to verify and validate for a particular domain or for a set of domains that your software is capable.
Yeah.
Now, we have a number of different companies from different industries paying us to have software in their systems, and they have to have that confidence that the software is safe and will operate safely in the system that it's operating in. So you have to say something really strong about your software. You have to be really you have to think really deeply about how you've designed that software so that safety is part of it from the ground up. I might give one example, an up-and-coming set of standards called SOTIF. It's called Safety of the Intended Function. And it's really interesting in that it implies that you need to check certain pathways or multiple pathways of your system so that you can validate online. Validation is really interesting. You want to be able to tell if the system is not doing the incorrect thing. Yeah. And that can happen at multiple levels. I might start with kind of the sensor side of things. You want independence and redundancy in those sensors. So independence meaning different ways of sensing the world. And we have three types of sensors that we work with. Camera, and that gives you the vision. LiDAR, which gives you range information. And radar, which is also range information, but at a lot larger distances, and also kind of brings extra capabilities in that it can continue to operate in really adverse environmental conditions, such as dust, snow, heavy rain. It almost gives you superhuman capabilities. So we're really excited about having these three modalities of sensing capabilities. They're both complementary, and also they can possibly provide a consensus.
I always had this sort of picture of like Superman with his laser eyes and can see through objects and stuff. But it's pretty much what you've got, isn't it? You are talking like superhuman kind of input potential. And of course, I mean, the environments that you're operating in some ways, I guess they're simpler potentially than a kind of passenger vehicle out on the road. But in other cases, there's a lot of extra complexity there. With mines are not clean places. There's dirt and mud and mess and muck all around, and ports and harbours are very incredibly dense, busy places. So there's a lot of complexity there. But and also with if you look at the on highway stuff, they're testing these things. They've got huge fleets of vehicles where they're out, testing hundreds, if not thousands of vehicles, clocking at millions of miles and hours of data to validate those systems. So it must be really difficult to do that with you can't have a fleet of 1,000 mining trucks just running test patterns for the next year or two. So how do you overcome that to sort of cover off all of the different possible scenarios that you might see?
Yeah. I think there's two ways that we address that. One is, I think the diversity in which we operate does help us. What we learn in airport helps us learn what's on a public road, or on highway, or in a dense urban environment, or in a mine. The corner cases that you come across in these different domains really wouldn't pop up in all those domains as often as each other. So we actually draw the learning across all those domains. So you don't need thousands of haul trucks, but you might use the different fleets of vehicles that you're working with in different domains to leverage the information that they learn, and therefore accelerate in different domains. So I think that's really key about this software autonomy platform. It doesn't just work in one fleet. It leverages all the information that you might get across fleets in all these different domains.
Really interesting. Yeah, I've always thought, if you or I are driving a vehicle or a machine and something happens, we perhaps have an accident. We might learn from that if we're lucky, and you might tell someone, but that's it. The extent to which there's kind of that mass learning event is pretty limited. So then same mistakes get repeated over and over and over again by human beings operating equipment and driving vehicles year after year after year, because the knowledge of the scenario stays with the individual. But that kind of collective, the ability to collect data across every deployed installation, I mean, it just seems like the learning curve should be very steep.
Oh, it is. I think it really is a huge advantage that autonomy brings. We'll never have a learner driver out in the road with an autonomous fleet. That fleet can only get better through all the learnings of every other vehicle. I think that's I think you really hit on it. When was the last time that anyone that individually went and talked to someone else other than maybe a person in their family or a close friend about an incident that they went through, so that they could teach others about how not to be in that kind of situation again? I think also what autonomy brings is you touched on it before, the kind of different modalities, the Superman laser beams. Now those laser beams are occurring in 360-degree panoramic view. The vision is also in a 360-degree panoramic view, same as radar. And I'm getting that kind of information at fractions of like 20, 30 hertz, fractions of a second, every fraction of a second. getting a full view of the world. So that information as well allows me to better understand what's happening in the environment, and be able to predict these particular types of situations.
You've got eyes in the back of your head, right?
Yeah. Poor old human has these tiny little square mirrors on either side of them, and the rear vision mirror, and that's all they've got, and you can only look at one at a time. So I think autonomy does bring this element of safety and learning across so many different types of vehicles, allowing the whole fleet or sets of fleets to accelerate their capabilities.
Yeah, the vision is a huge thing, particularly on larger vehicles. You know, a lot of people would recognize that on a truck, actually driver vision, you know, the trucks these days are kind of plastered in stickers that say things like, if you can't see me, I can't see you, for the driver. And obviously they've got pretty big wing mirrors, but kind of judging the distance from the front of the vehicle to the back of a 40-foot truck is quite difficult. You know, and I've driven some big trucks in my life, and I can honestly say those guys do it day in, day out. You know, it's there's a good bit of luck and as well as good judgment, obviously, and skill and practice, but it's really hard to judge those distances. But then you scale that up again to like a huge mining truck, a line haul truck, and the sort of depth perception and getting the sort of vision and view on those machines is actually a huge part of the design challenge of the machine in the first place, making sure the driver can see everything he has to be able to see by law. You know, those viewing angles are really tough to achieve on the big equipment. So that there must be a huge advantage with autonomous systems where you can place your cameras and your sensors basically wherever you think they're going to have the best impact.
Yeah, I'm in awe of drivers who are able to maneuver some of these monster machines, and I do think the sensing capabilities that the technology brings does definitely help and can augment that and create a capability that allows you to be have an understanding of the safety requirements of that kind of domain or that operation of that vehicle.
Yeah. So on Oxbotica, where do you guys typically sit in the market? So are you like supplying vehicle manufacturers who are deploying systems? Because we've seen some of the big off-highway OEMs. We had a guy from Volvo on a podcast a while ago who was talking about their autonomous mine project, and I know Cat have got a lot of work in this area. Are you dealing with OEMs, or are you tending to deal with the actual mining and quarrying, you know, the companies, the end users themselves? Whereabouts do you sit typically? Yeah,
we're definitely a B2B business, so we supply to other businesses, industries. You can call we're not specific to an OEM or a tier one or an operator. What you can do is call 1-800-Oxbotica and say, can we use your autonomy software platform? And we'll come up with a solution for you. We're able to deploy the entire solution, the entire platform, a full autonomy stack into that domain, or parts of it. It's quite modular, and you can use some of the tech. You might only want to leverage some of the technology of it. Maybe, for example, the localization system that doesn't require GPS, or the perception system for some kind of drive assist. All of those are available as a product or a solution for each of those domains. So we're not specific to a particular company. What we want to be able to do is accelerate other industries that can leverage what autonomy brings. And we've designed that system so it's easy to use. It's got open interfaces, for example, so you can plug in your own fleet management system, or you can plug in your own type of vehicle with its own set of sensors as well. Like, so we can plunk it onto an OEM's vehicle, for example. Right. So this is, I think, where there's some strengths in Oxbotica in the way that we're just looking at the software, but we ensure that you can interact with it, you can interface with it from many different levels.
Okay, and with that given, then it did sort of applications like a mining site, for example. You know, you might have all one manufacturer's equipment in a mine or a quarry. Okay, it's possible you might have equipment just from one manufacturer, but in a port, it's really unlikely. And an airport as well, really, really unlikely. You're much more likely to have 3 or 4 or 5 different manufacturers, pieces of equipment, moving things, shifting things, pulling things. So would that be then sort of where your software could come in as a bit of an advantage, and it would help help coordinate vehicles and machines from lots of different companies onto a common platform?
Absolutely, and it doesn't even have to be a common platform. What we provide is an open interface that allows others to either plug in their own modules or use Oxbotica's modules. So it really enables the capabilities of a heterogeneous fleet, different types of vehicles that are all different throughout that fleet, to be able to have the same capabilities, the same autonomous capabilities, even if they had different sensor and power requirements on each of those vehicles. We're able to supply that kind of capability to each of those vehicles. So I think it really opens up what you can do in each of these domains, and you're not beholden to any one type of platform, type of vehicle, or type of system. And that open interface allows you to do that. Set of open interfaces that allows you to do that.
Oh, right. Okay. Yeah. That makes a lot of sense. Because as these things get more and more complex with more different kinds of requirements and machines and vehicles, you're going to want to be able to pull lots of different things into that sort of. Would you describe that as like an operating system for a site, or how would you describe that?
Yeah, that's really interesting. We talk about the foundations of our onboard vehicle as an autonomy operating system, and you put apps onto it. And then you can also talk about the cloud infrastructure being an operating system or a cloud operating system in which you can add your different apps onto it. It might be Oxbotica's apps, but equally as well, you can add in your own custom apps as well, and you have that capability to do that. So I think that's probably a close analogy.
Okay. Oh, cool. Interesting. Yeah. And in the market, then, again, I mentioned it earlier, but all the hype is about passenger cars, typically. So there's a massive hype cycle around autonomous passenger vehicles. But the sort of real applications where, because I've got to be honest, I would quite like to have an autonomous vehicle. I'd get a bit of time back and, make that commute easier, even though in the current environment, none of us are commuting very far on a day-to-day basis. But the big applications where there's a lot of kind of potential for increasing efficiency, for saving money, even reducing emissions actually by making that fleet more efficient, are things like trucks, long-haul trucks in particular, the mining sites you mentioned, ports and things like that. So we're starting to see those kind of places deploy quite large numbers of autonomous vehicles, particularly in off-highway, I guess, because it's less it's not a less regulated environment as such, but there's less stakeholders than there are in a sort of open on-highway environment. What do you see as the key, like the most exciting areas at the moment for you? Is it the shipping, the port market, or is it mining or trucking, or what's the kind of big area that's really like, yeah, that's kind of, we've got traction there now, that's really taking off for us? Yeah,
I think the market is huge. You're right. There's a big hype around on-road, and we're absolutely in that. But there's also advantages and a rich market place where on-road kind of passenger vehicles is only one part of it. We've put a real focus in being able to transform some of these other industrial automation, transform the types of industrial automation that's occurring now. So mines and quarries are a big one that we have deployments in, that we're operating in. Shuttles is another big part that I think has a big thing to play in.
Okay.
And then there's also just moving goods. transporting goods is another big part.
When you say shuttles, just for clarity, you don't mean like space shuttles, do you? You mean small passenger transporting vehicles rather than spaceships. That's
sorry. Yes, you're absolutely right.
you guys did some pretty clever stuff. So you might have meant spaceships, to be fair. Yeah.
My engineering team their eyes might widen a little if I said something like that.
Yeah, and for tomorrow, guys, we're gonna have So like the kind of point-to-point public transport solutions that are moving people around campuses or cities or airports, that kind of thing.
I think those domains will transform very, very soon because of what autonomy brings.
Right. Yeah. And so those the markets that are really interesting, obviously they're ones where typically you've got some sort of payback on, you've got a driver cost. You've got these skilled people who are having to operate these large machines and vehicles, and they're quite expensive, and especially on some of the mine sites, there's huge shortages of people who are even willing to work. I particularly I'm going to offend you probably here, but are you Australian?
Yes, I am.
I always get that wrong, but phew, I managed to get that right. Didn't call you a Kiwi. So, no, right, I think I can feel the abuse coming in from people now. So, right, in Australia, obviously, you've got the fly-in, fly-out kind of big mining operations, and there's a real problem getting guys who are qualified and skilled and even want to work. There's massive skill shortage in that industry, so just fixing that one problem would probably give you quite a good return on an investment in an autonomous system.
Yeah, I think driver shortage has a big part to play in what some of the gaps that autonomy can fill. I think also it provides the possibility of drivers not having to do that fly in, fly out, and they may sit in the town that they're living in, the city that they're living in, not very near their family, and able to drive to work every day and go to a nice air-conditioned office and monitor multiple vehicles at once. And that, I think that is I feel like that's a real win-win situation. It addresses that driver shortage that you're talking about, but also the industry who's requiring to fill the driver shortage is able to do that through autonomy. So I think it's a market that's very crying out for this transformation.
And truck people always talk about trucking, and I've had arguments with people where they say, what about all the drivers are going to put them out of a job? But I mean, my father was a truck driver, and long haul truck driving is it's not exactly a lot of fun to be away from your family for days and days at a time, and so kind of sleeping in a quite uncomfortable small truck cab. Even the big guys in America, I think there was a time when it was seen as being a pretty macho, cool profession, whereas again now it's actually pretty hard getting people who want to do that for a living. Delivery around the town is one thing where you can go home to your family every night, but being out on the road for days, sometimes even weeks, on these very long haul trucking operations, it's a very very challenging job to do. It's not a lot of fun.
Yeah, I really hope we can help there and allow people to do their job not many weeks away from their family and in the comfort of an office or their own home, and especially in the days like this where a lot of people are working from home.
Yeah. So the other kind of big thing is I mentioned it before, and Oxbotica is doing on-highway work as well, and the on-highway environment is very regulated. There's lots of stakeholders, and there's a lot of debate about how realistic it is to expect autonomous vehicles on the road in the near future because of overcoming all of these sort of regulatory and political barriers and hurdles. What's your view on that? How far do you think we're kind of just at the beginning and there's 10 years of pain, and then it might kind of we might be seeing lots of AVs on the road, or do you think that actually we're fairly close and it's been being kind of pulled and pushed through? Where do you sit on that?
I think we're all learning about the regulatory policies, what's going to be required and what's not. And we're working particularly closely with governments, one of them being the UK, and they've been very, very supportive, and we're working together to understand what you need in the types of policies around autonomy, the regulatory environmental framework that needs to be achieved. In fact, we're working on a project it's called Endeavour, which allows us to work really, really closely with regulatory bodies, the government, and we can educate each other. We can learn what those regulatory bodies need. We're learning from the government what they require, and they're learning about autonomy. They're able to experience that autonomous system, understand how you can move people and goods safely using autonomy. So I think we're way beyond the start. And I think we're in areas where you will see autonomous vehicles in various places, right now, and that's only going to expand. I think I don't think we're going to see less autonomous vehicles in the future. I think we're going to see a lot more autonomous vehicles in the future. Mm-hmm. But we have to work with the governments, the regulatory bodies for on-road, but equally you do that in mining and airports. They have the same types of bodies, but different restrictions. Right. And you mentioned that before. So you have to work with all of those. And I'm going to talk about an ecosystem again. Autonomy can't just be done alone. I can't just deploy an autonomous vehicle by itself. There's the whole support structure around it, and that includes, the regulations, the policies, the safety requirements, and government buy-in for in all of these domains. Yeah. So I think we're really privileged to be able to work with some amazing government bodies and regulatory bodies to be able to move the whole autonomy and advance it.
Right. Okay. That's interesting. So probably, if I interpret that correctly, we are there's still a lot to do, but actually you see it moving fairly quickly in the on-highway environment, and then the off-highway environment, just kind of different sectors are doing things in different ways, but it is progressing as well.
Absolutely, yeah, absolutely, and I think many people are seeing the advantages of autonomy and really want to leverage those advantages. So it's been really fantastic to be able to work with these bodies and move this forwards.
Yeah, and I think one of the applications where I've seen the sort of a lot of noise and sort of public announcements around in the last year or so is harbours and ports, and obviously that is a sector that's been growing. With global commerce and trade, there's more and more things being shipped around the world, but there's some pretty big harbours around the world have made some announcements, and actually not really knowing what goes on inside a harbour, the numbers are quite staggering in terms of thousands of trucks operating inside some of these big ports that are then all being converted to autonomous operation over the next couple of years. And these seem to be plans. Well, some of them are already up and running with quite significant fleets in their ports, but there are others that are that seem to be coming, and some big announcements made. What do you think of that kind of that application, the harbour and port type application?
I agree. It's staggering, the number of types of vehicles and the number of vehicles and how much is moved, how many, like the goods that are moved, and not only the goods that are moved in those harbours and ports, but the people as well. There's whole bus systems just to get people from one part of the port to another, and same as airports, just dedicated to the staff. So I think it's a really rich, amazing market to have autonomy. Leverage autonomy, use the technology that is available. You're able to, I think, accelerate and really again transform the way harbours and ports, or continue to transform the way harbours and ports may work. And I think what Oxbotica is able to do there is able to, we were talking about this earlier on, where there's so many different vehicles in a harbor or in a port. The Autonomy software platform that we provide allows you to be able to work on each of those different platforms and have them be able to work together as a team or a networked fleet is something that I think is absolutely able to do in those types of domains.
Because in a way, there's sort of no point. Sometimes with a technology solution for a problem, it's sort of sledgehammer to crack a walnut, isn't it? Because you go, well, we've got a problem with drivers, so we're going to make the whole fleet autonomous. And that sounds great, but then you make the whole fleet autonomous, and actually you need as many software engineers and maintenance technicians to then make the whole thing work and keep it running, because it's so complicated and difficult to use and so high tech. Is that kind of something that you guys have been through? Do you see that as a challenge, or are you really trying to just make it so simple to deploy these things that it can sort of be done anywhere without causing a further skill problem in a different area?
So you're right. You could deploy Autonomy and have the technology and not have the tools, the interfaces that you need that allow people to use it in any effective way. Where absolutely we've by deploying into different domains, by working with different partners and customers, we over the years have learned about what kind of interfaces are required, how to make that easy to maintain, how to use, and our system. We have to make our system easy to use because it's got to work with different partners, different parts of the system, different vehicles, different fleet management systems. So we really had to focus on an understanding of how you make that simple for someone who's not skilled in autonomy but is an expert in their domain. We need to make sure that they're able to use this new autonomy tool and achieve better than what they were doing before, be more efficient in what they're doing. So it's really, really important to have those maintenance schedules, those tooling, the user interfaces that allow non-experts of autonomy to still leverage what autonomy brings.
Yeah. Oh, that's fantastic. Really interesting to see some of these bigger systems be deployed. And of course, you can imagine almost like public transport. You're operating lots of buses. It's just the mind when you start to think about it. Really, you suddenly start to realise there's huge, lots and lots of applications out there, both on the road and off the road. So what's just leading me on to the next question, actually being mindful that we're running out of time. So what's got you most excited about the future? What's coming for you guys the next year or so that you're really looking forward to?
I think what you're going to see from Oxbotica is we're going to continue to expand throughout North America and Europe. You're going to see our software platform on some of the domains that we just talked about, at least some of those domains that we talked about: mining, shuttles, delivery, and I think you're going to see it in further domains as well. I'm really excited to see these industries leverage autonomy and continue to leverage autonomy and really take on their advantages that autonomy brings. The productivity, the efficiency, and the benefit of this around safety.
Yeah, cool. So that's fantastic. I think we'll bring it to a close there. But it's been fascinating. I think we probably could have continued all day, but I know you have to get off, Ben. So we shall let you go. Thank you so much for taking the time out to speak to us today. I hope you enjoyed it. Sorry for hitting you with all those questions.
No, I've really enjoyed it. Thank you so much for the opportunity to have a chat to you, and have a great afternoon.
Thank you. So that's all we've got time for today. I hope you've got some value out of that. I certainly have. I've learned a lot about what Ben and the team are doing at Oxbotica. Very thought-provoking in terms of the future and what autonomy will hold for lots of different applications in the heavy vehicle industry, machinery, and on highways. So I'll put some links down below so you can find Ben and find Oxbotica out there on LinkedIn and their website and so on. Don't forget, if you've got any questions, please feel free to send them in to us. We'll try and turn those into episodes. And if you're involved in doing something really cool in the world of electric vehicles or autonomous vehicles like Ben and his team, you can get in touch and you could be a guest on the show as well. So thank you so much for taking the time out to listen to us today. That's all we've got time for, and I really look forward to speaking to you again soon.